Here it says you have a bag of 56 total Skittles. There are 10 green, 12 red, 11 orange, 9 yellow, and 14 purple. So now we're going to go through these 5 questions that involve this bag of 56 Skittles. So the first question says, let's say you close your eyes, reach into the bag, and pick one Skittle. What is the probability that that Skittle is red? So probability is calculated by, it's like a fraction. In the numerator is the number of desirable outcomes, the outcomes you want, and we want the 12 red. We want to know the probability of getting one of those 12 red. In the denominator, it is the total number of possible outcomes. So in this case, there's 56 possible outcomes. So this is the probability of getting a red. Now I can simplify this fraction, or you can divide to turn it into a decimal and then a percent and say, well, that's about 21%. Now let's look at the second problem. Let's say in this scenario, you close your eyes, reach into the bag, and you want to find the probability of picking one purple. So in this case, the desirable outcomes are those 14 purple Skittles. And there's still 56 total Skittles. So now I'm going to simplify this fraction, and I can also change it to a decimal and then a percent. There's a 25% chance that one Skittle is going to be purple. Now let's look at the next one. You close your eyes, reach into the bag, and pick one Skittle, and it's green, but you don't like green, so you put it back. So ask yourself, how many Skittles are in the bag? Still 56. Now it says you pick one Skittle. What is the probability that this Skittle is red? So even though you picked one and it was green, you put it back. So picking that green one, since you replaced it, does not impact the probability of picking that red Skittle on your second try. So these picks are what we call independent events. One pick didn't change the probability of picking a red on your second try. So in this case, it's like that first problem. How many red are there? There's 12 that are favorable outcomes out of, remember, there's still 56. So this is 3/14 or 21%. But if we look at the next one, it says you close your eyes, reach into the bag, you pick 2 Skittles. One is orange and one is yellow, and you eat them. And now you want to know the probability of picking a red. So in this case, if you pick those 2 Skittles, you pick an orange and a yellow, you don't replace them. So how many orange do we have? We have 10. How many yellow do we have? We have 8. So now we don't have 56 Skittles anymore. We only have 54. The first event, picking that orange and yellow Skittle, since we didn't replace them, that does impact that picking of the third Skittle. So these are called dependent events. Now I have 56, or not 56, I have 54 total outcomes, 54 Skittles, and still 12 of them are red. So it's 12 out of 54, and you can simplify that or divide and change it to a decimal and then a percent, which is about 22%. Now, the last question is saying, how many Skittles would you have to pick to guarantee that the next Skittle you pick is going to be green? Okay, so there has to be no chance that we're going to get a red. So those 12 red have to be out of the bag. These 11 orange need to be out of the bag. We have to have already picked these red, orange, yellow, and purple Skittles so that now the only color Skittle we can pick is a green. If all of those are gone and I only have 10 Skittles, then there's 10 that would be a favorable outcome out of 10. That's 1 or a 100% chance. So I need there just to be 10 Skittles in the bag and for those 10 Skittles to be green. So how many Skittles would I have to pick to guarantee that there's a 100% chance that there's a green? the other ones, if I add the 12, 11, the 9, and 14, I would have to pick 46 Skittles, and then that next one is 100% definitely going to be green.